All right, here's question 11 from the Chapter 6 quiz review. And on the quiz tomorrow, just be FRQs. I took the multiple choice off, or I'll probably post the whole thing, but you'll only be expected to do the FRQs. So in 11, let Y denote the number of broken eggs in a randomly selected carton of 1 dozen store brand eggs at a local supermarket. Suppose the probability distribution of Y is as follows. So if you look at this table, these are all the number of broken eggs. So you could have 0 broken eggs, 1, 2, 3, or 4 broken eggs. And the probability of each number of those broken eggs occurring. So part A, we're specifically asked, what is the probability that at least 10 eggs in a randomly selected carton are unbroken? Well, let's think about what at least 10 means. First of all, at least 10 means 10 or more in that dozen, so that's 10, 11, 12 eggs are unbroken. Or sorry, at least 10 eggs in a randomly selected carton are unbroken. Yeah, so at least 10 are good. So that means eggs 1 through 10 are good. That means what's the probability of having 2 or less be broken? So this is broken eggs. So this variable Y is broken eggs. So we're actually going to find the probability that Y is less than or equal to 2. Sorry, I'm writing with my fingertip. So Y less than or equal to 2, I go to my table. Less than or equal to 2 are these 3 probabilities. So I just add those up. I'm not going to show my work here because, again, I'm writing with my finger. But if you add 0.78 plus 0.11 plus 0.07, you get 0.96. And then B, calculate and interpret the mean. I got this right from AP, just posted how the formula sheet will look for you guys. So I copied this from the actual formula sheet. So AP just posted this. Here is all the formulas, and I'll add it probably to this post, and I'll add it several times the rest of the year here. So this came right from the AP formula sheet. So for a discrete random variable, ours is just called Y. To find the mean, you add every x times p of x. So 0 times 0.78 plus 1 times 0.11. I mean, so on. You see my work shown over here. And that mean, if you calculate that, I think you get 0.38. So on average, you'd expect to have 0.3 broken eggs in every dozen. And this question asks you to write that as well, but to save some time, I'm just going to skip writing it. But that's my interpretation. On average, you'd expect 0.38 broken eggs in each carton. C, calculate the standard deviation of Y and show your work. It's very likely they're going to ask you to show your work, especially on the format of the AP exam this year. So you don't have to memorize a formula. Here it is. Let me go back to this picture. So to find the standard deviation of a probability distribution, you sum every x minus the mean. So we just calculated the mean was 0.38. So I go back to my table and I do 0 minus 0.38. That was the mean. And then I square it. And then I multiply that by its probability. So for the first term of this sum is going to be 0 minus 0.38. So the y minus the mean squared times the probability of that y. So notice when y is 0, my probability is 0.78. I'm just going to go through a couple of these. The next one, so sum, I add 1 minus 0.38 squared. So 1's the next y value minus the mean we calculated. Square it and then multiply it by the probability that goes along with it. So that's 0.11. And so on. So you type all this sum in. Make sure you put it in a square root. I don't have the symbol. I just wrote SQRT for square root. And you should get a standard deviation of 0.822. And interpret it. So the interpretation of that is on average, in every carton, the number of broken eggs will be off from the mean by 0.822. So somehow word it that way, that you're saying average distance from the mean and in context, meaning here we're talking about broken eggs. All right, last part in question 11. A quality control inspector at the store keeps looking at randomly selected cartons of eggs until he finds a carton with at least 2 broken eggs. Find the probability that this happens in one of the first 3 cartons he inspects. So you see the word first. So I mean, this is screaming geometric to me. which means we got to check bits. And I marked on some of your homework quizzes that you actually need to write this out. So binary, for full credit, I need to write out bits and check them all. So binary, my two outcomes are broken or unbroken. I'm going to be very short here just so I don't waste your time typing. Independent. And these are cartons. There's no reason, and again, you have to write this. I'm just going to say it to save a little time, but there's no reason to think that each carton I pick up is not independent because he's doing it specifically randomly. So the fact that he's picking these randomly, I'm pretty sure these are going to be independent. And then T is for trials. We're interested in picking a carton until we get our first one with at least 2 broken eggs. So here, this trials is satisfied because we're picking cartons until we find our first carton with 2 broken eggs. And then last, success. I will write this one out. The probability of success here was at least 2 broken eggs is, we have to calculate that. So I go back to my table up here. So at least 2 broken eggs is 2 or more. So I would add these probabilities. So 0.07 plus 0.03 plus 0.01. That means that probability, when I add those, is 0.11 for each carton. So every time this manager picks up a carton, he's got a 0.11 chance for each of getting at least 2 broken eggs. So again, you make sure you write out all these on the quiz tomorrow. I'm just trying to save a little time. So now let's calculate that probability. So the probability this happens on one of the first 3 cartons. That means it could happen on the first, it could happen on the second, or it could happen on the third. So we're finding the probability that this random variable, I'm just going to call it x, it's geometric, is less than or equal to 3. I don't know if I have a less than or equal to symbol somewhere in here. I'm just going to write it like that. So I'm going to do a geom CDF of 0.11, 1 comma 3. And let's see what that gives me in my calculator. Not that calculator. Menu 65G. So I get a probability of 0.295. And that's it for question 11.